we introduced PartGlot, learning shape part segmentation from language reference games. 3D part segmentation is an essential task in many applications. However, typical supervised methods require manual part annotations on 3D shapes. Annotating parts on 3D shapes is a non-trivial task that requires lots of human hours and expertise. And such a challenge in annotation has been a bottleneck in dealing with diverse shapes amid the massive increase in the demand for parsing 3D shapes. Comparing with this, describing a 3D shape with natural language is a much easier task that does not require any expertise or lots of work. Hence, we propose PartGlot, a framework for learning part segmentation only from a linguistic description of a shape, without any part annotations. We demonstrate that referential language of a 3D shape can be leveraged to guide the learning process to discover semantic parts of the 3D shape. A linguistic description of a 3D shape can be easily obtained from a speaker and listener conversation about the 3D shape, which we call reference game. Given a triplet of shapes, we let the speaker describe the target shape, so that the listener can discriminate the target from the other two distractors. Since the characteristics of the target shape are usually depicted with discriminate parts, the listener can find the target while focusing on the described parts. Our key idea here is to build a neural listener finding the target shape while creating an attention module that discovers the semantic part described in the input utterance. Here is the PartGlot framework. First, there are 3 encoders that take an utterance and super segments of a shape as input. We use LSTM and a variant of PointNet as the utterance and super segment encoders. Then the feature of the input utterance and super segments of the input shape are fed to the attention module to compute attention maps. Refer to our paper for the crucial details in the design of the encoder and the attention module. Lastly, an MLP predicts a classification score from the outputs of the attention module and classification encoder. If a set of predefined part names is given in the training, PartGlot can leverage this as additional supervision, which we call the part name aware learning. Here, the attention maps are computed for all the part names and normalized over them. Then, the attention map of the part name, including the input utterance, is used for the target shape classification. In the inference time, if PartGlot is trained without the part names, we use a template utterance with a part name to obtain the attention map of the part. In part name aware learning case, we directly feed a part name instead of a template utterance with a 3D shape. The final part segments are obtained by normalizing the attention maps over the super segments and then taking the argmax of the attention maps along the part names or utterances. Here are some of our qualitative results. Compared to ground truth, both the part name agnostic and part name aware learning cases discover the semantic parts correctly. When the part names are given as additional supervision, PartGlot further improves the segmentation results, especially in challenging cases such as distinguishing between similar-looking arms and legs. Quantitatively, our PartGlot also achieves 79% MIOU in the ShapeNet chair part segmentation, which is comparable to the results of a supervised method. We also find that our PartGlot trained with linguistic descriptions can be zero-shot generalizable to the other classes of 3D shapes. For instance, when training with chair dataset and testing with tables and lamps, PartGlot detects the table top and lamp shade as chair shade, and also the table leg and lamp base as chair leg. Also, PartGlot discovers not only semantic parts in the 3D shape, but also corresponding words in the input utterance through another attention. The attention encoder of the utterance decides where to look in the target shape discrimination, and it attends to the proper part word in the input utterance. We also experimented with synthetic description about finer grained parts in PartNet dataset. As shown here, our PartGlot also accurately discovers the fine-grained parts. Please come to our poster at number 49 for more details. Thank you.